All right, so fundamental counting principle. First box there says if decision M can be made in lowercase m ways, so we're just some number of ways, and decision N can be made in lowercase n number of ways, so some other number of ways. The two decisions can be made in m times n ways. Okay, so if there are 3 decisions here, 2 decisions here, the whole way, there are 6 different ways of making that 3 times 2. So you're multiplying those decisions together is how that's going to work. So the first idea here. So the number 1 there says ice cream shop offers a choice of 3 cone sizes and 15 flavors and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? Okay, so certain situation here, this is a counting principle problem because we can only choose 1 of each. Okay, it changes if we can change, we can pick 2 or 3 of each. All right, so 3 cones, 15 different flavors of ice cream, 8 different toppings. We just multiply all 3 of those together. 3 times 15 times 8. 360 different ways to make a cone if you can only choose 1 of each. That's quite a few ways. Right? Imagine what it's like at Subway. All the different options there. That's one of the neat things about this. No wonder it takes those people in front of you in line so long to pick what their sandwich is going to be. Pick some bread, pick some meat, pick some cheese, and then put stuff on. All right, number 2, Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are there? So there's 3 letters followed by 4 digits. And one of the key things with fundamental counting principle is a lot of times if you'll make blanks in the for the different decisions. So 3 letters, we put 3 blanks there for letters. And then 4 digits. So I'm going to put 4 blanks there for digits. How many letters are there to choose from? 26. So the first choice has 26 letters. It didn't say anything about not being able to repeat a letter. So if I wanted to put, F, I could. Or A, I could put the same letter 3 times. So the second letter could be 26 of them and another 26. So all 3 of the letter choices could be the same letter. It may not be. It's up to us to make that. And then the digits. All right, so we're dealing with digits here. How many digits are there?
9.
Why 10? 0 is a digit. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 digits. So 10. Oh, let me write that in red. 10, 10, 10, 10. So there's all of these choices to make a license plate. Multiply those all together. That's a big number. So 26 to the 3rd power times 10 to the 4th power. That's what that is. Quicker to type in there. Wow. 175,760,000. Right? State of Tennessee. Huh? Is she at the office? Sorry. All right. So, state of Tennessee, what's the license plate style? Y'all know? You're drivers, so that's what we need to know.
Mine's just 4 numbers.
Just 4 numbers? But yours is yours a special license plate like ag or Wild Turkey Federation or something like that? So that's different.
I think mine's 6. 3 and 3.
3 letters, 3 digits. That's how a regular license plate, just normal ones. The special ones have different situations with those. But a regular license plate, which I got to go buy my tags for this year today, But it's 3 and 3. So it's much smaller number in the state of Tennessee for regular license plates, 26, 26, 26, and then only 10 to the third. So that takes off one of the zeros, which reduces that number to 17 million and something. So divides it by 10. So a lot lower number in Tennessee than in Virginia out of that. But interesting way. But the blanks are a good style of helping you get those decisions listed out. All right. Number 3, Nick's science class or test has a section with 12 true and false questions. How many different ways can Nick answer these questions? Okay, for each true and false question, how many answer choices are there? 2. There's 2, right? It's true or it's false. Or blank's not an option. If it's true or false, you got to put a T or an F in there. Okay. How many are there? 12. So we could either write out 2 12 times in the blanks, or we could raise 2 to what power? 12th power. And 2 to the 12th power, everybody knows that's 4096, right? Oh, no, nobody knows that. Some of us.
Mr. Islam?
Yeah?
Bring Hannah Henson to the office, please. She needs to bring her stuff. She'll be making a test.
All right. Hannah?
Also, Will Westbrook.
He is
He's
absent.
not here today.
Yeah,
Okay.
there you go.
Thank you.
All right. So, same number of decisions and multiple times you can use the exponents to help us do that instead of writing out that many blanks because it's the same number. Doing that. Number 4, enter the to enter their home, the Clayton family enters a 4-digit code. How many different codes are possible? A 4-digit code. So that's 4 blanks. How many digits could there be? 10 for each one. Hopefully, you don't make your code 0000 because that's the first thing that crook's going to try when they try to get in your house is all zeros. And all. I wouldn't think, or 1, 2, 3, 4. Don't make it that either. So that'd be 10 to the 4th power, which is 10,000 different codes that it could be. If you think about how many of you got a debit card? You got a PIN number with that. It's 4 digits usually. Some of the banks are doing 5 digits now just because it's added security out of that. So there's 10,000 different 4-digit codes that your PIN number could be.
No one ever asked for my PIN number. And it makes me mad. I want to type it in.
You're actually safer without typing it in. They're running it as a credit because you're protected by Visa or MasterCard, whichever one your debit card is. If you put in your PIN number, it's direct draft from your bank. So you're probably safer. Okay. Actually, you are safer. Dave Ramsey says you are. So, and he's right though. He's not putting out false information about that.
Yeah.
That if you don't put your PIN, if you put your PIN number in, it goes direct draft from your bank. If you just run it as a credit, then you're protected by the credit card company that issues
When I
it.
do type it in, I cover it up when I do it.
That's a good idea.
Watching.
That's a good idea. Don't let anybody see your PIN number. All right. Factorials. Factorials are really excited numbers. N. That's what that says. Read with feeling. Remember, y'all probably are too young to have had Miss Debbie Plunk at the elementary school, but y'all had. Oh man, I remember we used to have to read aloud in her class, and so you had to. If there was an exclamation point in there, you had to read it with an exclamation point. So I always remember that. So, but no, n factorial is how that's read in math class. It's the product of numbers from n to 1. So like the first example is 9 factorial. It's the product of numbers 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and work that out. The good news is your calculator has a button for that that we can use that would help instead of having to type that out. That really stinks to have to type it out. So with the graphing calculator, the factorial button is under the math menu. And then you go over to PROB for probability, and it's choice number 4. So the math button, go over to prob, option 4, and well, you need to type your number 9, math, prob factorial, hit enter. So pretty big number there, 362,880. Okay. So, and then you could do 12 factorial, 8 factorial, 1 and 2. I'm just going to copy and paste and then type in. Yeah, I messed up. Didn't do it right. Oh, well, good thing I know where it's at. 12 factorial is pretty big. 479 million. 1,600. Myself. 8 factorial should be smaller than 9 factorial. How much is it? Somebody's already done it. 40320. Now, here's the neat thing about 17 factorial divided by 11 factorial. If you did 17 factorial, you know it's this, right? And 13, 12, 11, and it keeps going, right? Divide that by 11 factorial, you know 11 is this, and keeps going. What happens is the 11 factorial cancels out all of those, and you just end up with 17 times 16 times 15 times 14 times 13 times 12. That's a nice thing if you ever have to do it by hand. I don't think you're ever going to have to do it by hand. Not for me, anyway. So, math, factorial for 17 divided by 11, math, probability factorial. 8,910,720. 8,910,720. 0 factorial is 1. That's by definition, 0 factorial is 1. Always. Kind of like anything to the 0 power is 1. 0 factorial is always 1. All right. Now, so factorials are just taking a number product of all the numbers, that number and lower down to 1. Okay, easy thing. Where's that used? Well, it's used in permutations and combinations. So the permutations notation is NPR. So that's how I'll say it most of the time, NPR. The arrangement or lineup of objects in which order matters. Permutation, order matters. Things that order matters in. Alphabetical order, arrangement. You see the word arrangement, you know it's a permutation. You see the word rank, it's a permutation because order matters. If you're talking about a race and how many different ways are they able to finish? Well, first place, second place, that's a ranking. So order matters on that. So permutation, order matters. Combination, order doesn't matter. Okay, so that's how you know which one, you're going to have to tell which one to use. Permutation, order matters. Okay, order matters. The formula for permutation is n factorial over parentheses n minus r factorial. N is how many objects are available. So if we're talking about people in a race, if there are 10 people in the race, n is 10. R is the number of objects you're using in the arrangement. So if we're wanting to know how many ways can the 10 people that are racing finish in first, second, or third, that would be 3. So that's 3 positions. Okay. So N is how many things you're arranging. R is how many you're picking for a group that you're going to be dealing with. So N is the total number of available. R is how many you're putting in that arrangement. Okay. N is how many there are available. R is how many you're putting in your arrangement or group. Okay. There's a shortcut if the number of objects you use and the number you're arranging is the same. It's just n factorial. So you don't have to, it just, if we've got 5 objects and we want to know how many ways can you rank 5 objects, well, there's first, second, third, fourth, and fifth. 5 and 5, it's the same. It's n factorial ways of doing that. Now, let's look at some permutation type problems. And I'll show you how a calculator can be used to help you do this. How many ways can you arrange the letters in the word dinosaur? So how many letters are in the word dinosaur? 1, 2, 3, 4, 5, 6, 7, 8. Are there any repeated letters? No, all different letters, 8 different things. Okay, so if we're going to arrange that, the key word is arrange, so we know that's a permutation. It's going to be 8 letters, and it didn't say arrange 4 of the letters. It just said arrange those letters. So our permutation is going to be for 8 of them. And we know that there's a shortcut to that is 8 factorial, but I'm going to show you both ways to get the permutation with your calculator. To get the permutation with your calculator, to get it to do that formula instead of you having to do it by hand, hit the math button, go over to probability again, and look at number 2. It's NPR. That's exactly what you want it to do. So I'm going to select NPR, and then I'm going to put in 8 for the number of objects and 8 in my arrangement, and 40,320, which we already knew that 8 factorial was that number because we did that on the previous example. 40,320. Number 6 says we have 7 students competing in the geography B. How many ways can they finish first, second, and third place? So this is a ranking, first, second, and third place. So we know it's a permutation. There are 7 students, so we know our number of people that could finish first, second, or third is 7. So the N is 7. Permutation of how many positions? 3 is the R. Okay. So I'm going to do math, probability, permutation 7, permutation 3. 210 different ways to finish first, second, or third. And I am on board with you using the calculator to do those instead of writing out the formula and having to calculate it out by hand. All right. Over to the next page. Number 7, Melanie's taking 4 classes this semester: American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged in her schedule? Okay. The word arranged tells me that that is a permutation. Okay. So how many different classes are there? 4, right? And then how many? So her permutation 4. How many classes is she taking? She's taking 4. Arranging that in a schedule. 4 factorial. I can do that in my head. 4 times 3 times 2 would be 4 times 6 is 24. Right? I can do that one without the calculator, but 24 different ways just to arrange those 4 classes. How many classes do you guys sign up for? 8, right? So Miss Bowen and the office help try to start making schedules for 550 students. 8 choosing 4 one semester, 4 another semester. Wow, that gets a lot of different ways of making it happen. So it's a tough thing to schedule. It seems like a hard thing, but it is when you start looking at the numbers of it. Number 8, say we have 16 players on the baseball team. How many ways can a coach make a 9-player batting order? We're assuming that they all are decent players or we all are horrible. It doesn't matter. So 9-player batting order. So batting order, that word order tells me that order matters. It's a permutation. So 16 players, permutation 9. Okay. So I'm going to use the calculator to help me, and I can just copy paste and help myself here. And enter. 4,151,000,000. 347,200 different ways to make the batting order. That's a lot. You think about the coach and making the starting lineup and all that stuff. That's a tough gig, especially when you got to make a lot of mamas and daddies happy. Doesn't happen so much when you get up to the high school level, but recreational level, ooh, most people get mad, but they don't know those numbers. All right, 28 students in Miss Miller's or Mr. Miller's homeroom. How many ways can the students elect a student council representative and an alternate? Okay, so that one's really disguised well as a permutation. It's hard to see that there's a ranking there because it doesn't say the word arranged or ordered, but it says you have a representative and an alternate. Which one ranks higher than the other? The representative is on the council. The alternate is not. So there is a ranking that's happening there. That one's really disguised well. So our permutation would be 28, permutation 2. Out of that. So copy and paste. $28, 756 ways to choose a representative and an alternate out of that. All right. Permutations with repeated parts. Remember when we did the word dinosaur, I asked, are there any repeated letters? There weren't any, but on the word automobile, there are. So how many different 10-letter arrangements are possible using the letters in the word automobile? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters, but we've got some repeated letters there. We've got the O's that are repeating out of that. So 10 letters would be 10 factorial. You want to divide out your repetitions. So for every piece that's repeated, you put a factorial for that, how many times it's repeated. The O is repeated twice, so you'd put a 2 factorial in there. If there were another letter that was repeated, say 3 times, you would put a 3 factorial in there as well. So if there's multiple repeats in there, you're going to use more factorials in the denominator. So you're going to divide that out. 10 factorial divided by 2 factorial. 10 factorial divided by 2 factorials, 2. 1,814,400. Number 11 says how many different 9-letter arrangements are possible using the letters in the word disappear. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. The repeats, we have a repeated A. There's 2 of them. There's a repeated P. There's 2 of them. So there's another 2 factorial in there. One of them represents the A that's repeated. The other 2 factorial represents the P that's repeated. And you divide that out. So 9 factorial divided by, and put parentheses around your 2 factorial times 2 factorial. $90,720 different ways to arrange. Notice those problems are not asking you to arrange a smaller set from that word. They're asking you to arrange all the letters in that word out of that. That's why we're not using the NPR stuff there, because that's where that comes from. All right. Next part is combinations. Combinations, the notation is NCR. Order does not matter. Okay? Order does not matter in combinations. The formula for combinations, n factorial over r factorial times n minus r factorial. Combinations, there are going to be fewer of those than there are permutations. Okay? The reason being permutations, if you take 5 things and put them in order, and then you just swap 2 of them, that's a different arrangement. It's using the same 5. Combinations just saying how many ways can I pick 5 of them. So there's going to be a smaller number. You can see in the formula that we're dividing by more stuff than we are in the permutation formula. So a combination is going to be a smaller number of things. But order does not matter. N is, again, how many things you got to pick from. R is how many you're picking for your group. So combinations, a good example of combinations is if I wanted to pick groups of 4 out of this classroom. I could take the 24 people that we have here and do 24 combination 4. And that would tell me how many different groups of 4 that I could make. Now, if I wanted to find how many ways could I rank the top 4 students in the classroom, that's a permutation. So there's a difference in forming groups and rankings or orders. Okay, so combinations, order does not matter. On the shortcut there, if you're trying to find combinations of the same number of things, it's just 1. If you got 55 things and you want to arrange, a group of 55 of them, well, there's only one way to do that. Or you want to group 55 of them together, there's only one way to do that. Okay, so it's just 1. So that's a super easy shortcut. All right, look at examples of that. Natalie, 16 close friends. How many ways can she choose 5 to be bridesmaids and have 11 people mad at her? So so we're choosing 5 to be bridesmaids. We're not ranking them in order. They're all just going to be up there. So 16 combination 5 is what that's going to be. Combination on the calculators in the same place that permutation was. So we're going to hit math, go over to probability, and it's choice 3. And I'm going to put 16 people, and I'm picking 5 of them. 4,368 ways to pick 5 people out of that. Okay. So 4,368 ways to pick 5 people. Not rank them, just pick 5, groups of 5. Okay. Number 13, 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So they're going to Sky Zone or something. It costs so much per person. So your parents said, we can only take 8 people. So 24 combination 8. How much would that be? 471, you said? Good job. So math, go over probability, pick NCR, and put those numbers in there. Same. Let's see. All right. So copy in your first number. So I'm putting 24, and then hit math. CR, and then you're picking 8. That's not going to give you the. All right, so if you're, so you'll have to type in your first number, then go get your NCR, and type in the second. Some of those. All right, now. So if you've got one of the black and white ones and yours is not coming up and allowing you to type in here in the little boxes, you'll type in your first number, then grab the NCR or NPR, depending on which one you're doing. And then after that, type the R number, the second number, and then it will crank that out for that one. All right. 14, Abby is adopting kittens from the pet store. There are 18. How many ways can she choose 2? Just choosing 2. We're not ranking them, we're choosing them. So we know that that's a combination. So 18, combination 2. $18. 153 different ways to pick some cats. All right. Number 15, there are 12 employees at the sub shop. How many ways can the manager choose 4 for the Sunday evening shift? Okay. Choosing 4 for the Sunday evening shift. Notice it's not one of them is a manager and the other 3 are underneath there. It's just choosing 4 people to work. So 12, choose 4. Just how much? 495 if you type that into your calculator there. 495. 16, 85 players on the football team. How many ways can you choose 3 to represent the team at the coin toss? So 85, choose 3. 98,000. Woo, that's a lot. All right. All right, next page in your notes are some more examples, and we're going to talk about whether it's a permutation or a combination, and then you guys can work it. All right, so we're going to go through and we're going to name if it's a permutation or combination, and then you guys can work it on your own there. So how many ways can 4 candy bars be chosen from a store that sells 30? Is that a permutation or a combination? Combination, because we're picking 4. We're not picking our 4 favorites or ranking them. We're just picking 4 from the 30. You should be doing 30, choose 4 when you work that out. Okay, so I'm going to write whether it's a combination or a permutation and then what the setup is, and then you guys can do the work. Number 2, how many ways can 13 students line up for lunch? That's a permutation because if we're in line, we're in order. So that's a permutation. So 13 kids, 13. We know that that's going to be 13 factorial, and y'all can work that out. You could also do this one with the blanks, 13 blanks, and you got, 13 kids for the first place in line, and there's 12 left for the second place, and you can keep going that way. A couple of different ways to do that one. Number 3, how many ways can you make 3-letter arrangements for the word letters in the word trapezoid? That's a permutation because it's arrangements. And so how many letters are there in the word trapezoid? 9. So it's 9P3. You work that out. And then number 4, how many ways can you choose 2 books from a shelf of 40? Is it a permutation or a combination? Combination because we're just picking 2. We're not ordering them, or ranking them. So it's a combination. It'd be 40, choose 2, combination 2 out of that. I swear that's how my son picks library books that he brings home. He just picks one. He doesn't really figure out what it's about. We read some random stuff. Number 5, how many ways can 12 swimmers? How many ways can 12 swimmers finish first, second, and third? Permutation, right? 12, permutation 3. Really, really easy stuff. 6, how many ways can Miss Sullivan choose 2 students from 27 to help put away calculators at the end of class? Combination, 27, combination 2. You have enough tickets to play 6 different games at the amusement park. If there are 14 games, how many ways can you choose 6 of them? Combination, 14, choose 6. Great. How many different ways can 9 trumpet players in the marching band line up? Permutation. 9, 9. We know that's 9 factorial. That's the shortcut to that. Get that number later. Number 9, 7 students work together on a project. How many ways can their teacher choose 4 to present the project? Combination, 7, combination 4. There are 18 offensive players on the hockey team. How many ways can the coach choose a left wing, center, right wing to start the game? So permutation, because if you're a left wing, you can't be the center, right? If you're the center, you can't be the right wing. So it's an order matters there because you have a position out of that. It's not a rank out of that, but it's a position. So that's a permutation. That's the kind of the tricky part of that one. 18, permutation 3. How many different 12-letter arrangements can be made from the word Indianapolis? Well, it's an arrangement, so we know it's a permutation, but we're going to do it with 12 letters. How many repeats do we have? That the I repeating 3 times, right? So that's 3 factorial for the I. The A is there twice, so that's 2 factorial for the A. And the N repeats twice, so that's 2 factorial for the N. So that's what's got to be there. So I tried to color code that. The I is happening 3 times, so that's the blue 3 factorial here. The A is happening twice, that's the 2 factorial there. The N is happening twice, that's that 2 factorial. You just work that out. Don't forget, if you're going to use the calculator here, put the bottom part in parentheses when you go to do that division. If you don't, it's going to give you a wrong answer. Number 12, last one of the notes here. If there are 26 goldfish in the tank at the store, how many ways can Ben choose 5 of them? Combination. 26, combination 5. You could go through and find all of those values out of that. All right. So got a little practice with this. You got about 30 minutes left in class here to work on this. It probably won't take you that much time to do this. Easy thing. Just recognize permutations and combinations. On the front there, you'll see, it's in order the way we did things in the notes there. 1 through 6 and stuff is going to be the accounting principle things. And then you're dealing with factorials, and then the combination permutation stuff, you're just finding those values. Then on the back, that's the word problems like we got there. See? Yeah, sure. So on the back is going to be like these problems, just situational out of that. I'm going to go back and write in the numbers that you should be finding on this. back up in just a second. We'll go. All right, so should be getting number one on the practice there. If you've already done it with the calculator, you just want to verify 27,405. Number two was 6,227,020,800. Number three was 504. Number four should have been 780. Number five should have been 1320. Six was 351. And seven was 3,003. Eight was 362,880. 9 was 35. 10 was 4896. 11 was 19,958,400. And then 12, 65,780. So there's your answers to those in the notes there. Working your way through the practice here. This will be a homework assignment, practice assignment, just like always. Tomorrow, I don't think I'll see you guys. Got that part. On the denominator, you do that division, you put an extra 7 parentheses, and then you do the 3 factorial. Well, if you don't have parentheses, you can all parentheses, what I'm saying is put a parenthesis that encases these 3. Right? You need another parenthesis U, and then one in front of that parenthesis. See how those parentheses? Group those two together, because you're dividing by all of those. And what yours is dividing by the fact 3 factorial.